Okay, we're here with another video. This time we're going to be looking at a table, and I happen to use presidents' names here, but they could be anything, of course. And we're going to determine whether or not the amounts the people were paid are proportional to the number of hours they worked. So money to hours, in other words, in that sense. And again, if you can't see that last word, it's number of hours over there, okay? So what we're going to do is take these and divide them. Remember how we talked about how time is usually X? And money is on top? That would actually make it Y. And based on the constant of proportionality, which I'm pretty sure we talked about, you probably can't see that. Constant of proportionality, sorry. Okay, the constant of proportionality is Y over X. So what we're going to do is just see if Y over X equals the same constant of proportionality, K. That's all we're going to do. So we're going to divide to do that. And again, we can't use a calculator, so it makes it super extra fun. So let's look at Ford first. We'll do his work first since he's on top there. We need to take his Y and divide it by X. So that's 7 3/5 divided by 1.2. 1.2 is also known as 1 2/10. So I'm going to use fractions to do this, but you can use decimals also. That'd be 7.6, so that'd be fine also. I just would prefer to use fractions. Either way is fine. Oh, so we got to change this to improper if we're going to be dividing these. So we might as well start that process now. 35 plus 3 is 38 over 5 divided by 2/10 is 1 1/5. So trying to reduce it, make life easier. 5 plus 1 is 6/5. So I got to flip it around to get 5/6. And that can change that to times now because I flipped it around. And then I can cancel out the 5s and divide these both by 2. So I get 19 thirds, which equals 6 1/3. So far, I got a constant of proportionality for Ford of 6 1/3. We got to divide these other two and see if they equal the same thing. Let's go to Carter now. Carter is 18 11/30 is the amount of money he earned, and that's divided by 2 9/10. So there's no reducing to do here. We can't reduce anything like we did last time with the 2/10. So we'll take 18 times 30 and add 11. That's going to be 540 plus 1, 551. 551 over 30. And we're going to change this to multiplication. So 2 times 10 is 20 plus 9 is 29/10. So we're going to go 10 over 29. Definitely can knock these zeros off here. Divide by 10 in both those. That's nice and easy. And then it seems like if I take these two, I'm not sure if 29 goes into 551 or not. So we're going to have to maybe just wait and see, I guess. I don't know. Why don't we see if it does? I just want to check because it's a possibility that it does. Let's divide it. We're actually cross-canceling here. I'm just seeing if 29 goes in evenly is all I'm checking. So it goes in one time. That's 29. And subtract and get 26. And bring down a 1. Let's see, that would be, it's awful close to 10 times. Let's try 9. 29. Let's move towards a little bit so you can see it. 29 times 9 is my guess. Let's try that. That equals 261. Awesome. So this is 9. 261. Save ourselves a lot of work here, really. So now that means I know this goes into here 19 times. Right here. 19 times. If you don't want to do it, you can long divide those whole numbers out too. So I get 19 thirds. Hey, that's awesome because that's the same thing I had before. So far, this definitely looks like they're proportional. Yeah, this is looking good. Okay, let's finish up Reagan now. Reagan's the last one. I'm going to do his probably on the bottom. Move down a little bit. Here's you have room here. See it? So we'll do his right here. On Reagan, he has 4 1/16, and he's divided by 5/8. So it's going to be 65/16 when we make that improper, and times 8/5. Well, this is good because I can reduce this too. Good, 1 and 2. 5 goes in once, and it goes into 65 13 times. Looking good here. So I get 13 over 2. Ooh, wait a minute. That's only 6.5, isn't it? That's different. That's 6.5. So that means that these are not proportional because... Okay, so the video cut off there for a moment. Sorry about that. But we found out that when we did Reagan's, constant proportionality, his equaled 6.5. which is different than the other two, which means really that there's no constant of proportionality, and this data is not proportional. So the answer would be no, not proportional.